Alright, so here we are with our properties of kites and trapezoids. We're going to use them to solve problems, both of them. So, here we are with our first image of a kite. It's a quadrilateral, meaning 4 sides, with exactly 2 pairs of congruent consecutive sides. So unlike a parallelogram, we're not talking about congruent opposite sides, we're talking about congruent consecutive sides, which means one after another. So that set will be congruent, and then that set. Alright, so we've got a few ideas of what happens when it's a kite then. So if a quadrilateral is a kite, so a 4-sided shape becomes a kite, then its diagonals are perpendicular. So it kind of happens just like a rhombus, but in this case we're talking about a kite. And then the next one is, if it's a quadrilateral is a kite, then only one pair, exactly one pair of opposite angles are congruent. So again, just like a parallelogram, opposite angles are congruent, but this is just one pair of opposite angles are congruent. And so if you're following along on our properties sheet, so I got it here at the end, we've got diagonals are perpendicular right here, one pair of opposite angles are congruent, and then we're actually going to, and then 2 pairs of consecutive congruent sides. So that's kind of its first definition there, and then we've got these last 2 that we talked about. So all of those can go in your kite understanding. That's not it. And so we'll use that. Taking a look, it does say it's a kite, and so of course, because it says it's a kite, we now know, for instance, this side and this side are the same, these 2 pieces are the same, this angle is going to equal this angle, and then they meet at 90 degrees. So you kind of get to put in a lot of things once you know it's a kite. Other than that, we also know that DAB is 54. So we know this angle is 54 degrees. Angle CDF, or CDF, so that's this tinier angle here, is 52. And we need to find the measure of BCD, FDA, and ABC. So we'll start with BCD, so B to C to D, so that's this guy over here. And so this is why we do triangles before we do quadrilaterals, because if you take a look at this top triangle here, we actually have a isosceles triangle. So if we have an isosceles triangle, and we've just said that this angle is 52 degrees, isosceles means this side and this side are the same, and also that this base angle equals this base angle. So we do know that this is 52 degrees as well. And so if we want to find, which we do, this top angle here, we can just take 180 minus 52 minus another 52, and we'll get our angle measure of BCD. And so our angle measure of BCD is going to be 180 minus 104, so 76 degrees. Alright, then taking a look at the next one, we're trying to find FDA, so that is down here. So FDA, let's see. Alright, that also comes from an isosceles triangle as well. So taking a look at our isosceles triangle of upper angle as 54 degrees, and then these 2 base angles that are going to be the same. That's one of them is angle FDA. And so if I take 180 minus 54, I'm going to get 126, and 126 degrees is going to be shared between these 2 angles. And so if it's shared, we're talking about 126 divided by 2, and so that's going to be 63 degrees for the measure of angle FDA. So kind of the backwards of what we did in the previous isosceles triangle. And then the last one, they want ABC, so that is this red angle over here. And we just talked about if we know This angle over here, we would know that angle that is across from it because they're the same. However, we did just figure out that if this was 52, then this was 52. And if this is 63, then this is 63. And so in order to find that one, we would just take the 52 from the first one and add it to the 63 from the second one. And that's going to equal our measure of angle ABC, so 115. Alright. So it's a good thing we did those first two before we did the last one. Alright. So moving on, our next piece is a trapezoid. It's always a weird word to remember, but a trapezoid is a quadrilateral, four-sided shape with exactly one pair of parallel sides. So as you can see, instead of two pairs of parallel sides, because that would be a parallelogram, we have one pair, and we call them the bases. So each of the parallel sides is called a base, and the non-parallel sides are called legs. So that's these guys over here. Base angles of a trapezoid are two consecutive angles whose common side is a base. So this base angle surrounds this base, and then these are kind of the upper base angles, and those surround those bases. So this is just terms that you're going to need to know as we're kind of talking about defining properties of trapezoids. Alright. So looking at our isosceles trapezoid, so thinking of an isosceles triangle, that means two sides that are the same. This is going to mean two legs that are congruent instead of two sides, because it's going to be the non-parallel side. So if we look at it, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So we've got this pair of base angles and this pair of upper base angles, and those are congruent if we have the two sides or legs that are congruent. So that's one property of an isosceles trapezoid. Another property of an isosceles trapezoid is that one pair of congruent base angles, if a trapezoid has one pair of congruent base angles, then it's isosceles. So it turns out that we only need to know, for instance, this bottom pair in order to know that it's isosceles. Or we only need to know this top pair in order to know it's isosceles. Alright, and then again, as long as we have a trapezoid, it's isosceles if and only if the diagonals are congruent. So we kind of talked about that when we talked about rectangles, because they also have congruent diagonals, but so do isosceles trapezoids. So, again, taking a look at our sheet at the end here, we've got a trapezoid. Yep, that's one set of sides that are parallel. And then going further to isosceles trapezoids, the legs are congruent, so that's that side. Remember, it's called a leg instead of a base. Those sides are congruent. The diagonals are congruent, or the base angles could be congruent. So depending on what your image looks like or what you're given. So we're going to use that in this next example here. So we're going to find the measure of angle A. And of course this is on its side from what we've been looking at, but it's the same idea. The bases are parallel, and we've got the legs that are congruent. And so if the bases are parallel and the legs are congruent, this is an isosceles. And so that means that the base angle are going to be the same. So this is 100 over here. And then whatever this other green angle is, it's going to be equal to the other one. And so in that case, if we have a four-sided shape which has interior of 360 degrees, if we take away the 100 from the top base angles, or that side base angles, we're going to have 160 degrees left. But then that has to be divided by 2 in order to be one of these angles. So if we divide 160 by 2, we get 80. And so 80 degrees is going to go for our first angle here, and then the other angle as well. And so that means that the measure of angle A is 80 degrees. Alright. Then moving on. Again, we have a isosceles triangle because you can see these two legs are the same, and of course our bases are parallel to make it a trapezoid to begin with. They're telling us that KB, which is this piece right here, is 21.9, and MF is 32.7. Where's M to F? Okay. And so we need to find FB, and it turns out that they are going to be congruent pieces. We've got this piece, which is JB, that would be the same as FB. Got an isosceles triangle, and the entirety of FM is 32.7. So kind of doing some proof work here. FB plus BM equals 32.7. And then if FB equals JB, we've got JB plus KB is going to have to equal 32.7. But we already know that KB is 21.9. So if we know that KB is 21.9, JB is going to have to be 32 minus that 21.9. And so our JB is going to be 10.8, or our FB is also going to be 10.8. All right. Our next one, we're trying to find the measure of angle F, which is a base angle. So it's going to be the same as this measure. But of course they only give us the opposite base measure. And so we know that if that one's 49, then this one's 49. And since the entire four-sided shape has 360 degrees inside of it, we need to subtract out two 49s for both of the bases. And we'll be left with, well, it's almost 100. 262, and from there we have to divide that by 2 in order to get these upper angles that are congruent. So apparently it's 131 degrees for the measure of angle F. So again, using the idea that an entire four-sided shape has 360 degrees, taking out the congruent base angles to then note that the top one is congruent as well, so divide evenly by 2. Alright, so we are trying to show that this is isosceles, and so taking a look at what they're giving us, AD is the diagonal, and that is going to be 12x minus 1, and BC is the other diagonal, and that's going to be 9x minus 2. And so we want to go ahead and find that value of x. In order to make it isosceles, that means that it was equal. And so the equal part is what we use in order to make it isosceles, and then we'd just solve to find x. And so let's see, I'll subtract a 9x to both sides, combining our like terms. And then I'll add an 11 over. And so we'll get 3x equals 9 and get an x of 3. So if we use an x of 3, that'll make this diagonal congruent to that diagonal, which means that we will have an isosceles triangle. I'm sorry, an isosceles quadrilateral trapezoid. Wow. That was a lot of words that I forgot. Alright. The next one is the mid-segment of a trapezoid. So this one's kind of thrown in there, but at the same time, hopefully it makes sense within this idea. So the mid-segment of a trapezoid is the segment that connects the midpoints of the legs. So notice that we have whatever this midpoint is, whatever this midpoint is, because it is a trapezoid and not an isosceles trapezoid, so we don't necessarily know that it is the same distance here and here. And so if we move on from that, what the mid-segment of a trapezoid is saying is that you can take this upper length, whatever it is, and average it with the bottom length, and that will equal your mid-segment. So your mid-segment is basically the average of the bases. So of course, what does that mean mathematically? The mid-segment of a trapezoid is parallel to each base, And so because it's parallel to each base, its length is a half of the sum. And so again, it just means the average. Add them up and divide by 2. It's also nice to know that this is parallel to these ones up here, just to help ourselves out there. And hopefully this looks like our midsegment that we did in a isosceles triangle, because we said it's half. And that's because technically this base length, if you will, is 0, and this length added to it would be the same, but then divided by 2 would make that middle piece. So this is in relation to isosceles triangles and how their midsegment is half of the base. So taking a look at this, we want to find the midsegment, which is EF. And so all we have to do is take our bases, which are 13.5 and 8, add them, and divide by 2. So if we add 13.5 and 8, we're going to get 21.5. Divide that by 2, and we're going to get 10.75. So that's our length of the midsegment. And then, of course, to switch it up a little bit, instead of giving you the other base, we're going to end up having a base missing, but we have the midsegment. So all we need to do here is say, well, initially I would have done 25 plus x. All of that divided by 2 would have equaled 16.5. So in order to work backwards, I'd multiply by 2 to both sides. So that's 33. Subtract a 25. And we get an x of 8. Which is, of course, EH. So that's the idea. This last page again was our properties of four-sided polygons. So we've got trapezoids, which was today, isosceles trapezoids, as well as kites. So those were all filled in today. So this entire sheet should potentially be something that you can use as a reference now, because we've gone through each of the pieces. So again, that was our 6-6 notes on kites and trapezoids.